Hi everyone. Today we're doing notes for 8.1% sales tax and discounts. One of the most common types of numbers that you hear used in everyday conversation is a percent. Unfortunately, most people do not have a good understanding of what percents really are and do not know how to compute needed percentages or percent changes. Consider the following headline that appeared recently in the newspapers. Illinois lawmakers pass a 67% tax hike. If the current tax rate is 3%, does that mean the new tax rate is 70%? What does 67% increase here really mean? So percents are going to be the focus of this section. So the word percent literally means per 100 or divided by 100. So the rule is we're going to move the decimal 2 places to the left when you're going from percent to decimal. And you're going to move the decimal 2 places to the right when you're going from decimal to percent. So we need to rewrite each of these following percentages as decimals. So 45% is going to be 0.45. 4% is 0.04. 232% is 2.32. And 0.04% is going to be 0.0004. Keeping in mind that percent is a part out of 100, now we're going to rewrite the following decimals as fractions and then as a percent. So 0.35, this is 35 out of 100, or 35%. 0.021, this is 21 over 1,000, or 2.1%. And 2.3, this is like 23 out of 10, which is 230%. Recall, to make an equivalent fraction, we can multiply or divide the numerator and denominator by the same number. So it says fill in the missing numerator and denominator on each of the following. So for this first one, we can see that we multiply by 4. So here, x is going to be 3 times 4, which is 12. For the second one, we multiply by 3. So for x, we're going to do 5 times 3, which is 15. I want you to do C, please. All right, in this case, we're multiplying by 2. So here we have x is going to be 4 times 2. So x equals 8. All right, so there are 2 ways to find. Method 1, if A is a percent of B, we have A is equal to P times B percent. And this means that the P is your percent part. So I like to rewrite this sometimes like this, P percent times B. And whenever you have this P percent, you're going to write it as a decimal. Method 2 is we can write this as a proportion. So A over B is equal to P over 100, or our part over the whole is equal to P percent out of 100. All right, so using our method 2, we're going to use equivalent fractions to rewrite the following fractions as percents. You can also do this by cross multiplying to solve the proportion. So for this first one, we have 5/8 equals P over 100. And so if we cross multiply here, I get 8P equals 500. We divide and we get P equals 62.5%. 2/5 is equal to P over 100. Again, we can cross multiply. 5P equals 200 and P equals 40%. I would like you to do C, please. Okay, we have 2/3 equals P over 100. Again, we can cross multiply. 3P equals 200. And in this case, P equals, we could say 66 2/3%, or you could say 66.67%. Okay, now we have to set these ones up. It says, what is 5% of 500? So I'll do this one using the percent equation. So 5% as a decimal is 0.05. So I have A is equal to 0.05 times 500. And so A is equal to 25. For our next one, I'll use the second method. 31% of what number is 83.7? So I have 83.7 divided by B is equal to 31 over 100. We can cross multiply. I have 31B is equal to 8,370. We divide and B gives us 270. I would like you to do C, and you can use either method 1 or method 2. Okay, I'll show this using method 1. It says 3 is what percent of 30? So 3 equals P times 30. Divide by 30. P is 0.1, which is 10%. Okay, sales tax. This is a percentage of the cost of an item that gets added to your bill to be paid to a state, city, county, etc. So the sales tax amount is your tax rate times the item's cost. So for 6 here, it says a computer is purchased for $1,025. Compare the amount of tax paid if the sales tax rate is 3% versus 5%. So for 3%, we do 0.03 times 1,025, which gives us $30.75. For 5%, we do 0.05 times 1,025, and that gives us sales tax of $51.25. For B, it says, what is the total cost of the computer if the sales tax rate is 6.25%? So 6.25%, we do 0.0625 times 1,025, and that gives you 64.0625. Now remember, this is money, so I have to cut it here, so it's $64.06. So I take my 1,025 and I add my $64.06, which gives us a total of $1,089.06. Now, another way you can do this is you can also do 1.0625 times our $1,025. This gives us the same total, $1,089.06. This is a shortcut you can use. Think about it. You're paying 100% of the computer, so that's 1, plus the sales tax, this is your 0.0625. If you add those two together, that gives you the 1.0625 to be the total you're paying for the computer plus the tax. Now, a discount, this is an amount or percentage of the cost of an item that gets subtracted from your bill. So the discount amount is your discount rate times the item's original cost. So a computer for 1025 is on sale for 15% off. What's the discount amount? So 15%, again, this is 0.15 times our 1025. So this is going to be $153.75. So the computer's sale price, we're going to subtract that out, 1025 minus $153.75, which gives us a sales price of $871.25. Okay, now there is another way we can do this in one step, kind of like we did with the sales tax. Remember, if you have 15% off, that means you're paying 85%. So you could also do 0.85 times 1025, and that's going to give you $871.25, which is the same as figuring out the 15% and subtracting it. Okay, so now this says, what would the price be if it were discounted 15% and then 15% of the new price were added? So we're going to use this discount price, which was $871.25. So now we have to add 15%. So 0.15 times 871.25. This gives you 130.6875. So if I cut it for the money here, the 7's going to round that 8 up. So this is $130.69. So I take my 871.25 and I'm going to add 130.69, which gives us a total of $1,001.94. So it says, be careful when you hear percents. You should always ask percent of what? In number 7, the 15% was computed from two different amounts, which is why we did not end up back at the starting amount. This is different from subtracting $15 and then adding $15, which would make us end up back at the starting amount. So here's another example of this. So we take 20% off of 100 and subtract it from 100. So we have 0.2 times 100, which is 20. 100 minus 20 gives us 80. Take 10% off the number you found in A. So I'm going to do 10% times 80, and this is 8. So 80 minus 8 gives us 72. So we did 20%, then we did 10%. So now we're going to try taking 30% off of 100. If I do 0.3 times 100, that gives me 30. Well, 100 minus 30 gives us 70. We can see these numbers, the 72 and 70, are not the same because, again, when you took that additional 10% off, you took it off of the $80, not off of the original 100. So again, it says, are the numbers the same from B to C? We said no. There's a different whole for part B. We only took 10% off of the 80, not the original 100. Okay, next we're going to do percent increase and percent decrease. So here we talk about the quote again. If the current tax rate is 3%, does that mean the new tax rate is 70? Unfortunately, it's not. In this case, they're talking about the percent change in the percent, so a percent of a percent. So if a weight increased from 8 pounds to 12 pounds, we could describe that increase two different ways. We could describe what needs to be added to the original amount, and one way describes what we would need to multiply the original amount. So to get from 8 pounds to 12 pounds, we would need to add 4 pounds. So there was a 4-pound increase. To get from 8 pounds to 12 pounds, we could also multiply by 1.5. So if 8 pounds represents 100%, then 12 pounds would represent 150%. So you could say the percentage increase in the weight was 50%. Because the original numbers are in pounds, it's obvious what type of increase we're talking about, whether it's 4 pounds or 50%. Where this gets confusing is when the numbers you're comparing are percentages themselves. So this gives us another example with percentages that we are going to go through in detail. So I'm not going to read through this one. So here I'm going to star this because it's very important. We're finding the percent increase or percent decrease now. So it's going to be the amount of increase divided by the original amount equals x over 100, or the amount of decrease over the original amount equals x over 100. So here we have a salary increases from 30,000 to 31,500. What percent increase is this? So again, our amount of increase we do 31,500 minus 30,000, which gives us $1,500 increase. So I take 1,500 divided by 30,000 equals x over 100. We cross multiply. We have 30,000x equals 150,000. We divide and x equals 5. So this is a 5% increase. I would like you to do number 9 now. Okay, for this one, we're doing a salary decreases from 31,500 to 30,000. So our amount of decrease, we take 31,500 minus 30,000. So this is 1,500. So that changes the same. We're just going the opposite direction. But let's check out the percents. So we have 1,500 divided by 31,500 equals x over 100. Again, we can cross multiply. 31,500x equals 150,000. We divide and we get x equals 4.76. So this is a 4.76% decrease. So our next one says, compute the percent increase in the percent for a tax rate that goes from 3% to 5%. So our amount of increase is 2%. We're going from 3% to 5%. So we have 2 over 3 equals x over 100. We cross multiply, we get 3x equals 200, and x equals 66.67. So that's a 66.67%, or we could say about a 67% increase. Which, if you recall, is what the lawmakers had said. A 67% tax hike, So that's about what this is. So that's going from 3% to 5%. All right. As we saw in the previous examples, percentages are easy to misuse. Consider the following examples. A store took its prices and reduced them by 35%. Later, it took those new prices and reduced them by 15%. The store advertises that now items are 50% off their original prices. Prove that this statement is false. All right, so our original is 100%. So it says they were reduced by 35%. So 0.35 times 100 is 35. 100 minus 35 means that we're paying 65%. Okay, then reduce them by 15%. So we're doing 15% of this 65 that we're paying. That's 9.75. So 65 minus 9.75, that means we're really paying 55.25% of the original. So they're claiming that the items are 50% off the original price. So our original, if it was truly 50% reduction, that would mean that we are paying 50%. But we just calculated if they do 35% off and then 15% off, we're actually paying 55.25% of the original, so we are paying more than 50%. So their statement is false. Okay, in a particular area, property taxes increased by 20%. A politician says that it will take a decrease of 20% to put taxes back to where they started. Prove that decreasing the new tax amounts by 20% will not put them back to where they started. So I want you to try to do this one, parts A and B. Okay, so if our original 100% and it says the property taxes increased by 20%, so that means we're paying 120%. So if we decrease this by 20%, we need to show that it's not actually where we started. So if we're going to do a 20% decrease, that's 0.2 times 120 is 24. 120 minus 24 means that we're paying 96% after the decrease. Okay, so we're paying 96% of the original amount. And so now B says find the percent increase or decrease as compared to the original tax amount. So our amount of decrease is 4, right? 100 minus 96 gives us 4. So if 4 over 100 equals x over 100, so x is 4. Now we are dealing with percents here, so you could also just see that paying 96% is just a 4% decrease. That's fine. You do not need to show the work. I'm just showing it here so you have it for an example if it's for one that's not working with percents. So again, this is a 4% decrease compared to the original. So again, it says be very careful of the following. When you see a percentage, ask yourself percentage of what? If the percentages are not of the same quantity, then you cannot simply add or subtract the percentages. When you see a percentage increase or decrease, look to see if the original numbers being compared are percentages themselves. And that's all we have for today.